Well, today's topic is stack and we want to implement stack using array data structure. As you know, stack works on LIFO basis, last in first out. It means the element which is most recently placed is always at the top of the stack and the element which is placed first is always at the bottom of the stack. And there are number of applications where we use stack, and some of those applications are converting the infix expression to postfix, evaluating the postfix expression, or reversing a string, checking the parenthesis, backtracking, storing the return address in function call, memory allocation, and compiler design. So, these are some of the applications where stack is used. In a stack, we perform following operations. Number one is push. Push means to add a new element at the top of the stack. Number two is pop. Pop means removing an element from top of the stack. Number three is display. Display means printing all the contents of stack from top to bottom. And number four is peek. Peek means displaying the topmost element. See, we are using static memory allocation for allocating memory for array. Static memory allocation means the memory will be allocated during the compilation time. It means the programmer will decide how much memory he wants. It means the programmer will be deciding the maximum size of array. So, what we have done? We have taken a constant max which tells the maximum size of array, and you can have elements from element number 0 to max minus 1, and we have taken one more variable which is top, and we have initialized it to minus 1 as initially our stack is empty. So, initially stack is empty, that is why top is equal to minus 1. So, let us discuss our first algorithm, which is an algorithm to post an element onto stack. Okay. So, our step number 1 is start. Step number 2 says if top is equal to max minus 1, then display stack is full. Basically, this is the extreme condition. It means if stack is already full, then you cannot add one more element. Let us take an example. Suppose we are implementing our stack using this array, okay, and these are the elements. Okay. So, we may fill elements from index 0, 1, 2 up to max minus 1. Okay. So, now let us assume if our stack is full. So, if our stack is full, then what will be the value of top? Top will be max minus 1. So, our step 2 says if top is equal to max minus 1, it means if stack is already full, then display stack is full and go to step 6. Step 6 says stop. Okay. So, if stack is already full, then we are not adding any new item. Now, what happens if our stack is empty? Okay. So, now let us consider the case where stack is empty. See, when stack is empty, what is the value of top? We had initialized top is equal to minus 1. Now, we will come to step number 1 start. If top is equal to max minus 1, no. So, I will come to step number 3 input the element to be pushed. Suppose element is 10. So, I will be inputting 10, increment top by 1. So, now top will become 0, okay, and this particular memory will be filled because this is a top. So, increment top by 1, assign element to a top. So, my element I have assumed my number is 10. So, 10 will be assigned to a top, okay. And after that we are stopping. Now, let us take one more example. Suppose we want to add one more item to this stack. So, start if top max minus 1, no, top is equal to 0. Come to next step, increment top by 1. So, now top will become 1. Okay. It means now we are talking of this memory. Top has become equal to 1. Assign the element to a top. Suppose my element is 20. So, 20 will be assigned here. Okay. So, in this way this stack will be growing and will go up to location number max minus 1. So, this is an algorithm to push an element onto stack. Okay. So, now our second algorithm is to pop an element from stack. Okay. So, now let us again draw the stack. This is our stack. We want to pop an element. Suppose we do not have any element in this stack. So, what will be the value of top? Top will be equal to minus 1. These are the indices 0, 1, 2, 3 up to max minus 1. Start. If top is equal to minus 1, then display stack is empty, because this is the extreme condition, there is no element. So, we will display stack is empty. Otherwise, what do we do? Display the contents of a top. Okay. For otherwise, I am taking example. Suppose top is equal to 3. If top is equal to 3, it means there are items at location number 1, 0, 1, 2 and 3. Suppose at location number 3 you have 40, at 2 you have 30, at 1 you have 20 and at 0 you have 10. So, normally our stack is from location number 0 to top. So, this is the stack now, okay, because top is equal to 3. So, let us see how our pop works here. Start. If top is equal to minus 1, no, top is equal to 3, display the contents of a top. So, what I will do? I will be displaying 40. After that, because I have popped 40, so after that what I will have to do? I will have to shrink the boundary of the top. So, what will I do? Decrement top by 1. So, now top will become 2. So, now our new top will become 2. It means now this is not part of our stack, although 40 is part of our array, but 40 is not part of our stack, because our stack is from 0 to top. It means from 0 to 2. Okay. Now, suppose again I want to implement it for top is equal to 2. Start. If top is equal to minus 1, no, top is equal to 2, display the contents of a top. So, now I will be displaying 30. Decrement top by 1, because I will be displaying it and popping it. Popping it means it will go out of the stack. So, what I am doing now? Now, I am decrementing top to 1. Okay. So, although 30 is present in array, but 30 is not part of our stack, because now our stack is from location number 0 to top. Top is equal to 1. So, our stack is this much. Okay. So, in this way we will be popping elements from stack. Now, let us see algorithm to display elements of stack from top to bottom. First of all, I will again draw a stack. See, this is my stack. This is max minus 1. Suppose this is 0, this is 1, this is 2, this is 3, this is 4. Suppose top is equal to 4. So, if top is equal to 4, it means our elements are from 0 to 4, because our stack is always from 0 to top. Okay. Let us assume these are the elements. Now, what we have to do? We have to write an algorithm so that we can display all the elements from top to bottom. It means we want to display 50, 40, 30, 20 and 10. Okay. So, how will we do it? See, we are not supposed to modify top, because if we decrement or if we increment top, then what happens? The stack is changing. Here we are not changing stack, we are just printing the contents of stack from top to bottom. So, that is why what we have done, we have taken a new variable temp. So, we have taken a new variable temp and we have assigned it value of top. So, initially the temp becomes equal to 4. Okay. Now, let us see how the algorithm works. Start. If top is equal to -1, top is equal to -1 means there is no element in stack. So, we will display there is no element in stack and we will stop. Otherwise, what we have done, take an integer variable temp. So, I have taken a temp, assigned top to temp. I have assigned value of top, that is 4 to temp. It means now temp also becomes 4. Repeat step 6 and 7 until temp is equal to -1. Now, what are the steps? First of all, display the contents of a temp. So, I will be displaying 50. After that, next step says temp is equal to temp -1. So, now my temp will become 3. Again, what will I do? I will display 40 and after that my temp will become 2. Okay. Because I am doing it until my temp becomes -1. So, now I will be displaying it and after that I will decrement temp, temp will become 1. I will display it, I will decrement temp, temp will become 0. I will display it, I will decrement temp, temp will become -1. So, when temp becomes -1 I stop. So, what has happened? Temp had taken value of top and has finally become -1. Okay, but the value of top has not changed because we never wanted to modify the stack. Stack is still from 0 to top. Okay. So, that is how we display elements in a stack from top to bottom. Now, our last algorithm is peak, where we will be displaying the top element. Means an element which is at the topmost position. So, this is quite simple. First of all, again we have to check for the extreme condition, because if there are no elements in stack, so there is nothing to display. So, that is what we are doing. First of all, if top is equal to -1, it means stack is empty, we will display stack is empty and we will go to stop. Otherwise, what we do? We display the value of a top. Suppose top is equal to 2. So, what we will do? We will display the value of a top, value of a top will be 30, okay, and we stop. Okay. So, in this way we have covered all 4 functions of stack, that is push, pop, display and peek. Okay. Now, you may try writing program, okay, a menu driven program for stack using an array.